The next we'll have Bobby Beniers, researcher of Polychain. The topic is a pragmatic path to an N-Rollup future. So let's welcome Bobby.
All right. Thank you guys for having me today. Today I'm going to talk about a pragmatic, not quite programmatic, but pragmatic path to an N-Rollup future. Motivation for this talk is basically, over the last year or so, we've seen this proliferation of different rollup SDKs, rollups as a service, OP stack, ZK stack, Arbitrum Orbit, list goes on and on and on. Kind of encouraging people to build their own rollups, application-specific rollups, et cetera. And they come with a lot of promises, scalability, kind of one-click deployment, customizability in kind of various different ways. And the motivation here is to kind of like think rationally about kind of what kind of future do we actually want. All these tools are great, but how do we kind of arrive at a destination that preserves the kind of user experience for kind of the end user, as well as the developer experience, like kind of not making that too complicated, as well as like keeping true to these core principles of crypto that we come to know and love, being like minimizing trust assumptions, maximizing kind of security and decentralization, and then maximizing that UX and DevX. So kind of to set the stage, wanted to kind of run through the debate that's kind of been happening in the space about kind of what are the benefits of a future that has kind of n different rollups and kind of what are the drawbacks. So starting out with the benefits, first and foremost, kind of like the general benefits of a rollup, you get these soft confirmations which are amazing and have really like kind of been this product market fit moment for users. They love these confirmations, kind of big unlock, right? Second is this amortization of fees across a bunch of transactions in a batch, which kind of can like loosely be understood as like horizontal scalability. There's kind of some complexity there. And then you gotta get into the more like app-specific rollup kind of unlocks. You get these choices when you want to build a rollup. You can choose between execution environments, like your sequencer setups, different data availability setups. Starting with execution environments, I think this is great. You can have different languages that potentially appeal to like a broader developer base. You can introduce potentially parallelization, a bunch of other things you can do here. And then sequencer setups, you can have that single sequencer for really fast soft confirmations. If you kind of trust the single sequencer, you can move to a more decentralized sequencer setup where you hope to still get those fast soft confirmations, but now you've kind of distributed that trust over a set of nodes. And then lastly, kind of this shared sequencer setup, which is a newer concept, but really great in the sense that you could potentially plug and play into a sequencer. Rather than having to kind of set up your own decentralized network. So a lot of exciting stuff here. And then lastly, data availability setups, which largely I think of as like a trade-off between the guarantees you want about your data and the cost that you're paying. So ETH call data right now, quite expensive, but strong guarantees. Dedicated DA layers hope to kind of like lower fees by breaking it out from execution and settlement. And then data availability committees are definitely going to be like the lowest cost, but the least guarantees. And then the last point I want to make is kind of this concept of developer control, which I think is like kind of less talked about. But there's this incentivization that people talk about in the Cosmos ecosystem of like if you own more of your infrastructure, you can benefit from more of the kind of the infra layer revenue via MEV or layer 2 fees. And then the last one is kind of like, most regulated companies definitely wouldn't be able, like you look at Base and think, Base wouldn't probably been able to happen if they had to put immutable contracts on the L1. Like they need to have some kind of ownership over their infrastructure to be able to kind of stay compliant or shut things down. So it kind of opens up all these benefits kind of open up the ecosystem of rollups to like a much wider base of potential users, which I think is really exciting. On the flip side, there's a lot of like vocal kind of people who are pointing out the drawbacks of kind of an N-Rollup ecosystem. First two, I think kind of go hand in hand, but this loss of atomic composability. So this is basically referring to like the DeFi apps that we know and love of today that synchronously build on top of each other. This is like one of, I think, many different crypto superpowers, but when you move to different kind of state, asset ledgers, execution environments, you kind of lose this synchronous programming capability. And then the second one is fragmentation of state as it applies to kind of like users and liquidity. So if you have DeFi apps across different execution environments, you're fragmenting kind of the liquidity needed for kind of liquidity pools or whatever, as well as kind of the network effects of Ethereum where all the users are kind of in one place and you get to kind of tap into that. The next couple, I think, are kind of being addressed, but we'll talk about them anyway. So one is application developer complexity. The idea being, if developers have to worry about their infrastructure as well as their application, prolongs the developer cycle, kind of also prone to maybe a larger attack surface if you have a bunch of different infra setups. But rollups as a service are this kind of really neat idea where people are kind of trying to take that on and abstract it away from the end developer. Ecosystem complexity is another concern. If we have all of these rollups, how do we kind of have wallets and sexes and fiat on-ramps, et cetera, like all plug into them. And I think these homogeneous architectures for rollups, whether it's like the OP stack or Arbitrum Orbit or the ZK stack, kind of address that, hopefully like modular enough to like plug in with all these different people. And the last one is kind of this idea of cross-rollup congestion via MEV and arbitrage. So if you have two DeFi apps on the same state, same execution environment, an arbitrage potentially takes like 2 transactions. And if you have them across different state, now you're looking at like at least 4 with the cross-rollup kind of transactions. This last one I'm not really going to talk about today. I think if we get to a future where cross-rollup congestion is a problem, like we've kind of done well. But for the purpose of this talk, kind of want to zoom in on points 1 and 2 and talk about how we can get the benefits that kind of this ecosystem provides while kind of addressing the drawbacks. So to start out, kind of want to make an analogy to the traditional software world. I'm sure everyone's quite familiar, but this is the concept of the API economy. When you're building a new web app or piece of software in kind of Web 2 world, you don't build pretty much anything from scratch. You tap into these APIs for your login. If you want to have like a social component, you use an API there. Payments, of course. All of these different things is basically like a plug-and-play game that you play in application development. And notably, this is all kind of asynchronous. Like these API services don't happen on the same server as your application. You're making asynchronous calls, and that's kind of created a user experience that's quite acceptable to billions of users today. So moving back into the crypto sphere, we actually have a great example of this already happening today in the Cosmos ecosystem. Via IBC, their inter-blockchain communication protocol. And kind of this community in particular has embraced this asynchronous programming model and pioneered kind of the use of light clients to enable it, which I think is really exciting. One concrete example of this, recently passed Proposal 810 on the Cosmos Hub has, in the near future, you'll be able to pay fees on the Cosmos Hub in whatever IBC token you like as a function of an asynchronous call to Osmosis, which is a DEX on a different chain, where they swap the tokens to Atom and then you give them to the validators back on the Cosmos Hub. So like I said, this kind of thing is happening, and the question becomes like, how do we kind of apply this model to an N-Rollup system? And notably, we want to do this in a way that, again, minimizes our trust assumptions, maximizes the user experience, maximizes the developer experience, et cetera, et cetera, et cetera. So today, kind of 3 technologies that I want to explore. Kind of the point here is that this like toolbox and this design space is kind of vast and an interesting place to spend some time. But we're going to go through like kind of state committees, ZK light clients, and then kind of some of the more like theoretical stuff around shared sequencers. Which I'm sure the like teams of these shared sequencers have some ideas as well, but I'm going to kind of present some as well. So the first model that we're looking at here is basically like most of the bridges you know and love today kind of follow some variation of this state committee model. In the example I'm showing here, you have a proof of stake, or you have optimistic rollup number 1 on the left, optimistic rollup number 2 on the right, and kind of sitting between you have this proof of stake network where nodes in this network are kind of keeping track with optimistic rollup number 1, executing the state on a full node, and then kind of attesting to that state, and signing some block header and sending it over to optimistic rollup number 2, where you can kind of like easily verify that the attestations did come from a majority of the nodes in the network by just checking against their public key. This is kind of like, in my opinion, best case scenario. Worst case scenario, you have multi-sigs. You can easily swap this out for kind of an optimistic setup and make all of these nodes watchers instead of kind of attesters on the front end. But like I said, this is kind of the model that we've seen most prominently. Also interesting, like you could swap out the economic security of this proof of stake network for eigenlayer restaked ETH, and now you're tapping into kind of a broader economic security base. So this model has like worked moderately well, depending on kind of the assumptions that you make. Latency can kind of have like a wide range, but typically like not good enough for this like asynchronous seamlessness that we're really looking for when we try to apply this kind of API economy model to an N-Rollup system. Kind of moving on, trying to get to ZK-like clients. First, kind of just want to set the stage with a basic setup of a couple of ZK rollups settling to the same settlement and data availability layer of Ethereum. The point here, mostly, I assume most of you kind of like know how this works, but just to kind of talk about finality, which becomes like a very important part of this conversation. So like a user sends their transactions to a rollup, it gets sequenced, the prover generates a validity proof of the batch, and that depending on what kind of VM you're working with can take anywhere from minutes to many hours. So I'm just gonna like, in a very optimistic case, say that proof takes like 10 minutes. And then once you post it to Ethereum, it gets verified quite quickly by verifier contract. And then you have to kind of wait for this 2-epoch probabilistic finality of Ethereum to kind of like know that your transaction is just as kind of set in stone as any other transaction on the L1. So to get that, just for easy numbers, I'm gonna say like 25 minutes to finality here for like very best case. Now, another idea to introduce before we kind of combine them together is this concept of ZK-like clients. This is a graphic thanks to the guys at Polyhedra who have built a great implementation of this. But what we have here, a little bit busy on the diagram, but just very simply, you have a sender chain on the left and a receiver chain on the right. You want to generate a proof that the consensus of the sender chain has come to consensus on a block. Then you want to send that proof and a block header to a receiver chain. Receiver chain verifies the proof and then kind of extrapolates state from the block header. So this kind of ZK-like client architecture is really great, and when you combine it with ZK rollups in this scenario, we'll talk about optimistic in a sec. You get this kind of really interesting trustless interoperability system. So like I said, 25 minutes to finality with the system we just talked about. And then you have over at the bottom right here, just kind of like this concept of there are some actors, Polyhedra and Succinct among them, who are proving Ethereum consensus and can kind of like relay state via a light client of Ethereum consensus on different rollups. Again, quick to verify. So this is like a really great model for ZK rollups. Optimistic rollups kind of have this 7-day finality window. So it's a lot kind of more difficult to like directly apply this model, but we'll talk about kind of other ways to do that. Yeah, and then kind of the bottleneck here becomes L1 finality. So obviously on the Ethereum roadmap, people are looking at how can we implement single slot finality, which would be a big unlock here. And then the other thing to optimize for to make this kind of like seamless, as clearly 25 minutes is not today, is to increase like kind of how fast you can prove things. So ZK prover technology, fast finality, kind of the blockers here. Kind of now is where we get into like, okay, if we want all of these rollups to be like highly modular and have all of these options for different kind of sequencing setups and DA layers, et cetera, things become really complicated. So just focusing on shared sequencing, just kind of quick brief on what that is. Pioneered by Espresso in Austria, kind of all it does is, takes the transaction mempool from a bunch of different rollups and, orders them together and, comes to consensus on the ordering of multiple rollups and then puts them in a block, relays that block to a bunch of different rollups who can kind of execute the, attested ordering. The question is, on shared sequencer, I actually could not have asked for a better introduction to like why consensus matters, so thank you very much. In order to maintain this soft finality principle, soft confirmation feature, you're going to want to have very fast consensus, which is where hotshot, which is a derivation of hot stuff, comes in. Austria is also looking at kind of Comet BFT or Tendermint to do this. And so the idea here is, decentralized sequencing, plug and play, really great properties for new rollups that want to spin up, and maintaining that soft confirmation feature. So the question becomes, how do we take this shared sequencing and apply it to kind of the model of seamless interoperability asynchronously to create this like great programming experience and ecosystem that isn't completely fragmented. So this is a hard question, kind of an open question, but I'm going to kind of talk through some ideas here. So it's great. We now have a bunch of rollups that are receiving ordered transactions of a bunch of different kind of rollups kind of natively as a function of this shared sequencer. The question is, can you create like transaction dependencies, so therefore atomic transactions? So like I want to burn this token only, I want to mint this token only if it gets burned on kind of rollup 1. And to do that, kind of ordering isn't quite enough. You can imagine like, yes, you see 2 transactions come through, and they're in the correct ordering, but one of them's kind of invalid, and then the system kind of breaks down. So you also have to do some execution here. So in order to do that, you could potentially run a full node of ZK rollup 2 on ZK rollup 1, and in that way kind of get an assurance that the ordering is correct and the validity is correct. But in my opinion, at this point, where you're kind of at a stage where you might as well just kind of like run one rollup. There's potentially some benefits to this, and I'd be curious if other people in the community have thoughts. But generally, I think this is not endgame. So then we go back to ZK-like clients and say like, okay, what if we instead of running a full node on these different ZK rollups, ran like similar to what we were talking about before, like a light client of the consensus of the shared sequencer. Now, great thing is like you don't have to trust any full nodes to properly validate the transactions. You can rely on math and zero knowledge proofs. But also like we're kind of still in this state where you don't actually know if the transactions are valid or not. So you're kind of running into the same problem. Again, like big design space to explore whether or not kind of you can do interesting things with ordering and not validity. But at this stage, like it's not like kind of obvious in the same model that we're proposing from before. So now we can kind of like try some things. What if we kind of proved, put the light client to prove validity as well as consensus of the shared sequencer? And now, definitely unproven, but like, is this kind of the same order of magnitude proving time as kind of just the validity proof that we started with? Kind of seems redundant to me. And then the question also becomes like, great, now we're using validity and ordering as kind of the basis for bridging, but like what about data availability? Are we kind of like sacrificing some of our trustlessness here? So kind of like the complexity continues to snowball, and my thought is like, okay, should we just go back to this original setup that was like quite clean? Then again, we got to remember, what we're trying to do here is we're trying to allow for these rollups to use whatever configuration of modularity they would like. So, you want to have people that, can plug directly into a decentralized sequencer network if that's what, suits them. So, the likely model here is, to have to start aggregating proofs from each broken out layer of ordering, data availability, and settlement. Other approaches that could be interesting to use shared sequencers for interoperability that have been talked about are like, could we use crypto economic guarantees to incentivize builders to kind of add our transactions in the order that we kind of need them to be? Definitely a big design space here. What those crypto economic guarantees are is also kind of like unclear. And then the last one is like, if we, similarly, we're moving to the block builder level instead of kind of the ordering level. If we use a decentralized block builder network, could we enforce with smart contract logic basically our intent to have two transactions, a mint and a burn, in the same block? I've seen some more experimental approaches. I think this is like a really interesting space to spend some time, and I don't have all the answers today, but I think it's an interesting problem for sure. Like I said, as we continue to break out kind of DA and settlement and ordering, this complexity gets pretty massive. I think faster provers, like I talked about, are definitely something that helps unlock our ability to have this seamless asynchronous communication between rollups. Also think these kind of, these different layers, while increasing complexity, potentially open up a design space for, better solutions. But at the end of the day, this is becoming like massively complex. So kind of wanted to talk about some things that like probably need to happen for this to, get back to our core goals of like a great user experience across different rollups. A couple of things that came to mind for me, definitely not one size fit all, right? This kind of ZK-like client architecture only kind of works when you have fast finality. So optimistic rollups are probably going to have some state committee component, hopefully with strong trust assumptions. But basically, you're going to need to compile together a bunch of different routes. And to that end, I think a hub and spoke aggregation model is really interesting. Axelar kind of already does this and is like planning on plugging in with Polyhedra and Succinct and a bunch of other people to kind of layer these together and route a bunch of kind of data across different trust assumptions. Also think it's really important to start thinking about abstractions and standards for this kind of asynchronous communication. I really like the kind of design of interchain accounts and interchain queries from the Cosmos ecosystem. They kind of allow developers to not have to like kind of think about the underlying IBC protocol and just kind of make a query across chain with an abstraction. Also shout out Polymer Labs, who's working on kind of extending this kind of IBC specification or this transport layer outside of the Cosmos ecosystem and to like ride on top of ZK-like client architecture. Tooling, I think, is also going to be super important. I think this kind of category is broad, but a couple things I'll call out is like Axelar is doing some cool stuff with like interchain tokens, which I find interesting. As well as kind of like interchain governance and kind of managing contracts across different chains. Catalyst is doing some cool stuff with like designing an application that is natively like cross rollup. So kind of this space is kind of very new as the technology is itself. And then lastly, I talked about at the beginning, but like how do we get infrastructure support and like buy-in from kind of all the different parties that we need to like make this ecosystem somewhat seamless. So that includes like your wallets, on-ramps, centralized exchanges, et cetera. Basically just like as we build this thing out, that is more complex than most other things we've ever seen in crypto. How do we kind of align all parties to make this UX kind of seamless for the end user? Some other extensions, I talked about kind of if you have everything I've talked about today was mostly like Ethereum as a settlement and DA layer. Like, what if you break those out? Kind of like, what other proofs do you need? Also, thinking about, is there some interesting like different kinds of proofs that we can do on maybe just like data availability to maybe potentially skip some steps, but likely you run into some problems there. So. And then the last thing I think that is interesting is, relayers. I've talked a lot about like we're proving things and then like sending things. Like who is sending these things becomes an interesting question. And how do you incentivize them to do so? Most of these like relayers are, you only need one honest party to like send the thing, and you'll have your guarantee based on the math. But I think it also is an interesting question of like, can we make this kind of an economically sustainable, like kind of relayer world where we pass all this information around? Kind of like the internet works today, which is kind of where I started. Kind of in conclusion, like if we solve all these problems, should every app be a rollup? And like the answer is like squarely no. I think, as I said, crypto has like a number of superpowers. One of them is kind of, synchronous communication and composable DeFi. So it's my expectation that like moving forward, we'll probably have some of these like meccas for like synchronous communication that share a state, and we'll continue to have these really cool DeFi apps that build on top of each other and kind of continue, the structure that we've seen so far. But that said, I think there's like this really interesting unlock for all of these new types of applications. The ones that want to kind of service kind of others in an asynchronous way, similar to the API economy. Infra from kind of regulated companies that need to come in and have a little bit more control over what they're building, but still want to be part of our world. I think we should encourage that. So kind of, I think the future is quite heterogeneous, and I'm quite excited about it. But the last analogy I'll make is like, kind of, if this future arrives, I hope that like switching between chains, interacting is like more like opening a new tab in your browser rather than like opening up a new laptop. So that's all I have for you today. Thank you guys for listening. Feel free to reach out and talk to me about some of this stuff. I think it's really interesting.